Welcome back to another episode of Data Protection Gumbo. I'm your host, Demetrius Malbro, and today I have two special guests joining me. And I have the pleasure of speaking with Dr. Ali Sekmen, who is the CEO at Pangea Tech Consulting, and also Chris Jones, Chief Technology Officer. Dr. Sekmen, how are you? Mr.
Ve-
Jones, how are you as well?
Very good. Thank you very much.
I'm doing all right. Good to talk.
All right, let's start off with you, Dr. Sekman. Can you give us a brief introduction of yourself and your background?
Thank you, Demetrius. Absolutely. And again, my name is Ali Sekmen. I'm the founder and CEO of Pangea, which is a technical consultancy company. I'm going to talk about it a little bit. But I am also currently a professor of computer science at Tennessee State University. I'm the former
Go
chair of
Tigers.
yes, and I am the former chair of the computer science department. I served in that capacity for 13 years. My background is actually in electrical engineering. I have a BS and MS degree in electrical and electronics engineering, and I also hold a PhD degree in electrical engineering and another PhD from mathematics from Vanderbilt University. So my background is engineering, math, computer science all together, and I'm currently working on research in theoretical AI and machine learning. And Pangea, after I stepped down as a department chair, I started up this company, which is located in Nashville, Tennessee. And it's a very interesting company. Yes, that's a technical consultancy company that uses AI and machine learning to solve challenging data science and engineering problems. Our team is an interesting team. We have over 35 people with PhD degrees in computer science or engineering, with strong academic backgrounds, strong funded research, but also practical industry experience. We specialize in building AI and machine learning systems from ground up, or we can retrain existing systems for higher accuracy and robustness. And robustness is extremely important, as I will talk later. We can typically tackle complex challenges that is beyond the capabilities of ordinary technical consultancy firms. So I'm going to let Chris
Okay.
introduce himself.
All right.
Hello, everybody. My name is Chris Jones. I'm a graduate of Tennessee State University. Go Tigers.
Go
Got
Tigers.
got my bachelor's there, got my master's there, almost have my PhD there. I'm an instructor as well. I have a bit of a more businessy background than Dr. Sekman. I have owned and run businesses. My company, Connective Incorporated, back in the late 90s, early 2000s, we did web design, database programming. Ended up having three sites that went to the finals in South by Southwest, and one that was recognized as Webby worthy, which is not bad for a couple of guys in a one-bedroom apartment. Shh, don't
Not
tell
bad.
anybody. uh, and I am also, a computer science instructor working on my PhD. My interest is high performance computing. I like AI ML as well. I chose to focus on bioinformatics at TSU because that's high volume data, high performance computing. Dr. Sekman asked me if I'd be interested in participating in this, and I was like, absolutely, let's do it.
So I welcome both of you to Data Protection Gumbo, and we are, switching it up a little bit with a segment quite like this one. And number one, I want to thank both of you for your service in teaching the youth and teaching those and training them to immediately go into the workforce and learn things like artificial intelligence and machine learning and all the other different disciplines around computer science, because we know that we are in a digital transformation, and I think we're well beyond digital transformation now. We're just in the age of quantum computers and AI, ML,
Mhm.
and also you need to keep that secure as well. So you have to mention cybersecurity also. So why don't we start off? I'm hoping everyone by now knows what AI and ML is, artificial intelligence and machine learning, but I want to ask you both, and I'll start with you, Dr. Sekman. What are the building blocks, just from your perspective, what are the building blocks of AI?
Actually, that's a very good question, and I know many people uses AI and many people uses ML. But I want to give like my perspective of what is AI, what is ML, and then I can talk about what are the building blocks of AI and ML. Okay.
All right.
So, in very simple terms, AI simply deals with development of software systems that can handle the tasks we normally think only human beings can handle. Think about driving, right? And until like maybe 10 years ago, maybe 15 years ago, we used to think that driving is a human thing, right? In order to
Mm-hmm.
drive, we first sense the environment using eyes, ears, and some other sensing mechanisms that we have. But sensing is not enough. We also perceive the world. When I look outside, I can immediately see how many cars are out. I can estimate their speed, pedestrians, traffic lights, all the comprehensive perception of the world, right? Once
Right.
I perceive the world, then my brain can process that what I perceive and do decision making. So driving was special to human beings, but now we have self-driving cars that can sense better than what we do. They have better sensors. They can see far away with LiDAR and some other sensors, and they can perceive the world. But that perception of the world requires a lot of training, as I will explain. And then they do decision making. So driving a car is a good example of AI now. Okay. Another
Okay.
example is right now. For example, in this podcast, three of us are talking, right? So Demetrius, I know you before. Now you talk and I recognize what you're saying. So speech recognition is important communication mechanism for us. But aside from recognizing what you say, I understand what you're saying, right?
Right.
So natural language understanding is another example of AI. Okay. But think about this podcast. We are having this podcast. If we have another one next week, we are not going to start over the conversation. We are going to build on it, right?
Right.
Because you learn about us, you learn about Pangea, and you learn about my expertise. And even as this podcast progress, your questions are going to get deeper because you're going to know more about us. So learning is another aspect of what AI. In fact, AI is at a point right now. Maybe the person you are talking right now is not me. Maybe that
Yeah.
really, I mean, we
Right.
have that technology right now
Mm-hmm.
that can fool you as if I am Dr. Sekmen in this podcast. It can use my audio, it can use my facial expressions, it can use my face, it
Deep
can
fake.
even
Right.
make it is bigger than that. It can even make jokes that I typically do with you. So that's where we are now. Actually, I
Okay.
have been involved in human robot interaction for years. And we have a very big robotics lab at TSU. And from 2003 to 2007, our focus was social acceptance of robots. Think about the robot. We don't have friends. We don't get friends with robots at this point because there are some barriers on that. But we were working on social. For example, one of my graduate students developed a very interesting robotic system early 2007, about like 17 years from now. And I asked her, hey, I want to come to the lab and talk to the robot and ask the robot to handle a task for me. And the task was this: I walk into the robot detects all the faces in the room, and out of those faces, it recognizes my face and says, "Hello, Dr. Segman." But that's not a static conversation. It even has internet filtering system. It goes to CNN.com, ESPN.com, filters the current news. So have a dynamic conversation. And when I talk to the robot, I say, hey, I will have visitors. That as soon as the robot recognizes visitors keyword, says, hey, let me go to the elevator and navigates to the elevator with path planning, mapping, obstacle avoidance techniques that we developed, and goes to the elevator and waits. As soon as people get out of the elevator, it recognizes detects the faces, starts a conversation again, and as soon as it hears Dr. Sekman, oh, you want to see Dr. Sekman? Let me take to the lab, right? So this
Yeah.
was
And
17 years ago, and most of those things were challenging at that time, but it is not anymore, really. So
right. Right.
what are the building blocks? Let's come back to your question. But of course, we need to understand what machine learning is, right? Machine learning is a sub area of AI, and it focuses on development of algorithms and models so that the machines can, how do I say,
And Dr. Sekman, before we jump into machine learning, I know it's important for us to link that
uh-huh.
one as well. We're going to come back to that. I want to
Okay,
throw Chris a curveball since he has all
sure.
this wonderful experience and he's a current professor as well. So you defined AI, Dr. Sekman.
Yes.
Chris, can you define generative AI?
Generative AI based on data which has been fed to it, either text, a text corpus, images, that sort of thing. It identifies elements that are relevant and generates presumably new text, new images based on what was requested by some user. The it is I have a problem with using the term AI because in my mind AI means AGI. Okay, it means human level intelligence. The generative AIs we have now are pretty good at doing making text, explaining things, summarizing articles, creating strange images with too many fingers, etc. But I'm not sure that there's any intelligence there. I mean, it is taking past information, recombining it, synthesizing it, and outputting it. But I'm not sure. I don't know what intelligence is. I don't have a good definition internally.
All
That's
right. Yeah.
definitely useful, but I'm not sure it's AI. It's a thing that we can do now, and I like it, but I'm not sure it's artificial intelligence yet.
Hmm. Okay. And looping back to machine learning, why don't you go ahead and tie that into this for us, Dr. Sekmen?
Absolutely. Actually, generative AI, a couple of years ago, I did a demo in one of my classes, and I was
A
actually
couple
one
of
of
years
the,
ago?
yeah, one
Wow.
of the graduate students made this demo, and it was senior projects class, and the senior project class heavily builds machine learning systems.
Right. Right.
And one of the graduate students came to the class and started speaking on microphone. He said, "Well, can you build a neural network that has 5 hidden layers and blah blah?" Define the neural network by speaking. And Python code was generated by AI. I mean, you see, and that's a scary moment because coding is done most likely more efficiently than many of the students can do. And that was like eye-opening moment. So that's
Right.
impact of AI. But let me define machine learning. So machine learning is a sub area of AI. Okay. And it deals with development of algorithms and models that can learn from data and predict from data without being programmed. And there are that's the main or predominant way to implement AI systems today, but there are other ways as well. For example, rule-based systems, expert systems, evolutionary systems like genetic algorithms and things like that. There are other ways. But there is a concept called deep learning. The deep fakes and all those keywords come from
Yeah.
that. Deep learning is a sub area of machine learning that deals with use of neural networks in building machine learning systems. So neural networks are the revolutionary or the most important part of current AI implementations. So what's a neural network? That's a very simple building block. Okay. Should I go ahead and explain that?
Oh yeah. Yeah. Go ahead. Hmm.
Think about an object recognition system that we want to develop. So let's say that we want to classify 1,000 different objects using a machine learning model. When I say a model is like a black box with tons of parameters in it. For example, ChatGPT is a black box. It has about 2 trillion parameters, 2 trillion.
Wow. Yeah.
So when I say the model, it's not like 10. So the even simple neural network models have thousands and thousands of parameters. So that's simply a dummy model that you start with. You randomly initialize all those parameters. Okay. And then in order to build that model, you need tons of samples. If you have 1,000 class of objects, probably we are going to need about 10,000 from each class. So tons of images, right? Every time I feed an image, I say, hey, here is an image of a car. And this is the model, dummy model, that's randomly initialized. But I tell the system, I supervise the system. I tell the system, here's an image of a car, and this is what you expect. You expect a car. And then it passes through this model. Of course, it's going to be totally nonsense because the model is random. Then it looks at the error, at the output, says, hey, this is what I expected. This is what I got. So what is the error? And then we have a technique called backpropagation and stochastic gradient descent kind of optimization techniques. And then those model parameters are updated a little bit. Every time you feed an image, model gets better and better and better,
Right.
right?
You're training it.
Finally,
Right.
exactly. Finally, you get that. So that's what a neural network is. It is a model building an optimization system, simply. And
Nice.
I started using neural networks in 1995 when I was a very young undergraduate student. And at that time, there was a limitation. So the revolution that we are seeing right now in AI, it all started in 2012. Okay. Because until 2012, we had neural networks, but we didn't have a special neural network called convolutional neural networks. We used to have it, it was introduced in 1998, but the computational, it was so heavy. So in 2012, a group led by Lacoon developed or implemented convolutional neural networks, and they competed in ImageNet competition. ImageNet is a competition in computer vision community. There are like 17 million images in ImageNet dataset. And every year they give certain number of images for training a model and certain number to test. Until 2012, the best was about 60% kind of accuracy, best algorithm. But
Yeah.
all of a sudden it became 80% with CNN. And right now it is over 95%. It can even recognize objects better than we do, Demetrius. So
And
that's just,
yeah.
and
Have you
that
heard of reCAPTCHA from Google?
Yes, sir. The
Yes.
the the security control entry to
uh,
sites and whatnot.
Right, yeah. So
yeah,
when you're presented like with a website or something and they
of
want you to
course.
verify, right? You have to click all the red lights, right? Because and I heard that you're actually training a model on the back end to recognize.
Yep,
It's
you are.
Google's smart way of doing that, right?
That's
I
correct.
guess the original was Yahoo, right? No, maybe I'm wrong. Yeah,
Eh,
the
it
original.
it could
I
be.
remember maybe incorrectly. Yeah.
Yeah.
So Dimitri's convolutional neural network is the first thing 2012 that changed everything. Okay,
Mhm.
and then in 2017 there was another milestone by Google. That is transformer networks. So transformer networks is a different neural network architecture than CNN. Okay, and that transformer network architecture is what we have behind ChatGPT. So
Right.
with this one, we were able to build large language models. Okay, and that's the second one. And let me give you a scale of ChatGPT. As I said, it's about 2 trillion parameters. And in order to train ChatGPT, they use data that can be read by a human being in 20,000 years. So those
Wow.
models learn from data. Well, there's a big issue here because, yes, they can learn,
Yeah,
but
yeah.
they need so much data than a regular human being. So that's the
Hmm.
challenge right now.
And processing power as well, because there is an issue right now
Exactly.
with GPUs. And I just read something about Sam Altman looking for an astronomical amount of money, like $6-7 trillion
Oh
that
my
he
God.
wants people to invest in chip technology for to power the hungry beast of
Yeah.
AI, right?
Yeah, Nvidia became one of the most powerful companies just because that's GPU using AI. Because
Hmm.
they power Google, they power other big companies, and they generate AI chips. And that is, it's not just the money, but they are the power behind all of this. Really, the hardware
Right,
guys.
right.
Yeah.
So let's talk a little bit about Pangea.
Okay. Cool.
And what are you guys doing over there? And I know you just recently retired or stepped down. I'm not sure what you're calling it, but
It's not
it-
retirement. I'm still
it's
a faculty.
oh, you're
Yes.
still there. Okay, all
Yes.
right,
Yes.
okay.
Yeah.
But tell us about Pangea and what you guys are doing there.
So that's a good question. So when we start up with Pangea, we were confused as well. And we had a couple of initial ideas, but right now, as of today, we are so firm about our direction. We completely understand where we are going, and we have a couple of avenues for us. The first
All
one
right,
is Pangea. The first thing that we did, Pangea got all the approvals so that we can submit government or we can compete for government
nice.
contracts. Okay,
Congratulations.
exactly. So, and in fact, I'm very happy to tell you, we even submitted our first small business innovative research SBIR
Mm,
grant to Department of Defense,
okay.
and it's about theoretical AI ML again. The Department of Defense, actually, Navy has a problem to detect mine and to detect and identify mines. Actually, they don't have a problem; they can do it, but they have a challenge. Hey, can you develop an AI and ML system that can do that? That can do what we do right now with much more limited sonar data. So instead of giving us tons of data, they give us very limited amount of sonar data, yet we should be able to identify the mines, detect and identify. So what we propose to them, fifth shot learning. Basically, we said we are going to build a model using all available sonar data. It doesn't even have to be underwater sonar data, because sonar
Right.
is sonar. Frequencies are different underwater or on ground. But we built a neural network system, a large model, using all existing sonar that we can capture. But then we develop some advanced mathematical techniques that differs Pangea from others. Okay, so we don't just build regular models. So we can get into anywhere in the model, and we can change anywhere in the model. For example, the training concept. We can change the whole training to make systems more robust. So then we do advanced high dimensional geometric concepts, manifold geometry, and understand the geometry of the feature space that is created by this model. Then when the Navy gives us the limited sonar data, we locate them on those geometric shapes. But to make it simple, it's a very
Yeah, make it
innovative
simple for us.
technique, innovative technique that can detect. So that's one direction. And now we are working on another SBIR to NIH. We are developing AI-based data management and analytics systems for research animals, specifically mice and rats, that is used in
Mm,
research. There are about
yeah.
90,000 research labs in the US. They use mice. There are
Hmm.
they are miserable animals. Unfortunately, my heart was. I mean, when I saw them, but there are 110 million mice annual use in the United States only. So we are developing a software system that's not just going to help the researchers, but improve animal welfare as well,
Hmm.
so that we
Hmm.
can protect the animals. The third
Yeah.
one is highly related actually to your security, cybersecurity. And maybe Chris should explain that. We are also working in
Okay. Yeah.
SBIR to National Science Foundation. I think it might be more interesting to your audience. Chris, you want to explain that?
Yeah, sure. It's a cybersecurity podcast, so everybody knows about encryption, etc.
Hopefully.
Homomorphic, yeah, homomorphic encryption has been around for a while, but it seems to be gaining some traction right now. It lets us work with data in an encrypted state. Okay, so not you can have your AI model living on Google Cloud, and you already transmit your information there using SS, and it's encrypted. It gets there, it gets decrypted, run through the model. The results are encrypted, sent back. Well, you can build, theoretically, you can build models that do the operations on the encrypted data. So it never has to be decrypted. So if Google has some sort of security incident, your data doesn't go AWOL. Uh,
Really?
yeah. And also, one of the things about ChatGPT is trillions of parameters, right? You transmit your data encrypted. It arrives at whoever servers your model is running on. It gets decrypted. They run it through the process. They do the analysis. They return the results to you, also encrypted. But while it's on this third party server, it is decrypted. It is in the clear. This is really important for things like medical data because you can't let that happen if you are the person who produced that data. It's against the law, basically.
Yeah.
So, using homomorphic encryption, we think we can do the analysis on the encrypted data. Okay, we basically just on the encrypted data, and then your data is never at risk, even
Right.
if Google has a security breach of some kind.
Okay.
One thing even further, which is very speculative at this point, we may be able to encrypt the model as well, so that
Wow.
Google is just providing memory and horsepower. They can't access the parameters of your model, they can't access the data either. And it's not that I don't trust Google, but I mean, things happen. So
Yeah,
that would,
absolutely. It's privacy.
yeah, so that would be a good thing. And we're looking at that. That is, I'm working on a PhD. I know some math. I'm banging my
Okay.
skull against a bunch of thick books and papers right now.
So you're saying that that doesn't quite exist yet, and that's something that you
Exactly.
are developing, because I was thinking of a question, like for instance, they say Chat GPT is the data. Be careful the data that you feed into Chat GPT, because it becomes public information, helps to train the model, and you never know when some information you put in will be regurgitated back out to someone else in a prompt that they actually put into Chat GPT. And I was wondering about, where was there a way to keep all of the data, especially like if you could tap, let's say you had one large trillion
Model.
model, right? That's the big model. But can you build a little model with just your data in it that pulls from the big one, but yet keeps
Oh yeah,
your
yeah, yeah.
your
Okay.
data secure based on what you prompted to do? That's what I wanted to know.
Actually, I can. May I go ahead and answer Chris on this? I
Yes,
was going
please
to
do.
talk about a concept. So it is not exactly the answer to your question, but there's a
Hmm.
concept called transfer learning, and
Transfer
that's what I
learning.
transfer learning. So let's say that I build a very large model using my own data and my own resources for object classification, general object classification. And but you are not interested in general object classification, but you're interested in facial expression classification,
Hmm.
right? So there are two different problems, right? Or two different domains.
Right.
But if you start from scratch with a random model, it's going to take tons of time for you and tons of computational power to build your own model. And it is shown experimentally that if you start with an existing model from another domain that may be remotely related to what you do, and instead of random parameters, you start with those parameters and train additionally on top of it, then you can, and your model will be less computationally heavy and it's going to be more accurate with the
Okay.
same computation. So that's called
Okay.
transfer learning. One
Mm.
advantage of computers on us, actually, it is a little bit scary to me because
Mhm.
let's say that three of us right now here, right? Everybody have different, I don't want to say intelligence level, but everybody have different intelligence.
Right.
And that your intelligence is based on genetics, but also cultural experience, social experiences, education, and so much, right? Mine too. Three of us, for example, you can come and teach me. You can transfer some of your knowledge to me, but you cannot transfer your intelligence to me, really, because it is specific to you. It is your self-awareness, and
Yeah.
it is
Yeah.
very different. But machines, so as a human being, that is something limiting us. 10 very smart people can come together, but we cannot say that they are together 10 times smarter than the group, right? Each one.
Right.
But for machines, think about a million computers. A million different computers can process things in a distributed fashion,
Yeah.
and then they can build on top of each other. So
Attackers do it
that
all the time.
yes, and that is from AI perspective, and they can do transfer learning too. So
Right.
computers, I agree with Chris. It's very difficult to say that they're intelligent at human level at this point, but that's the scary part because they can learn quicker than us, and they
Yeah.
can handle certain tasks much better than us, like driving a car, as I said. They still
And
lack
yeah.
intuition. They don't have intuition.
Yep.
But what if
Yep.
they get that too? What if they get that consciousness that they don't have now? They have cognition at a level that
Hmm.
a cognition is a very complex thing, right? Cognition, I mean, it is not an easy thing. It includes perception, attention, memory, language, reasoning, problem solving, and learning. So humans are very good at those. Okay, we have very complex thoughts, creativity. We can adapt to different situations, and we have intuition. Machines do not have it, and humans have some kind of self awareness, but
Yeah.
machines do not. But the scary part is if they learn how to do it, they're gonna do it quicker than we do. That's
Right. And
a flip. Yeah.
let's begin to wrap up here. And we only have time for one more question. And I want to ask a question that may help someone out in the audience, right? Maybe they are a current college student, maybe they're at Tennessee State University, or maybe they're
Mhm.
somewhere else, right? And we all know that artificial intelligence and machine learning and quantum computers, it's the future, it's the wave. It is where everything, it's where the puck is moving, right? And also cybersecurity on top of that as well. What advice would you give to an undergraduate student, and maybe even someone who's about to graduate right now, and they're still trying to figure out what profession that they're going to go into, and they're not quite clear or sure? what advice would you give them today in order to maybe steer them in the right direction of what to get into or what profession?
Well, I'm going to go ahead and give a little perspective on this. This is a very tough question. And the answer is not straightforward, because if you had
Mhm.
asked this question 5 years ago, I will give you a straight answer. But
Mhm.
knowing that now AI can generate better code than many of the students or recent graduates, even better than professors, they have
Wow.
optimized code. So coding is not challenging anymore. So if you're going to be a computer scientist, you should become computer scientist. So you
Mm.
should focus on science aspect of it. Everybody can write code, everybody can program, but not everybody can develop algorithms. Not everybody
Mm.
can develop uh, different theories. So it becomes very competitive to become a good computer scientist. Okay, but
Mm.
if you become one, you are the one who's going to shape AI in future. I don't
Okay.
believe there is a single job that is safe from AI.
Right.
So I'm being very careful with what they advise the students, because I'm also
Yeah, yeah.
confused by myself at this point. Really.
We are as well. And Chris, what about you?
Yeah, I would add, and I'm not trying to suck up to your audience, although it's going to sound like I am. Dr. Sekman's right. I mean, AI is going to touch everything. Okay, it's going to change everything. I'm not afraid of it. I don't think we're all going to end up being jobless serfs living on the dole or anything like that. But Dr. Sekman's right. Low level, not low level, simple coding tasks can be automated. So that is a thing that is true today, and it's just going to become more true. We still need people who can think and solve problems. One thing that's going to be very important is cybersecurity. I can help with that, but I don't think it's going to, well, I mean, it's going to, who knows what's going to happen, to be honest. But I don't see any clear path for replacing humans in cybersecurity at this point.
Hmm.
But
Right.
it's definitely going to be something that you guys are going to have to understand a little bit. And there's going to be blockbuster products that come out that make your job easier based on this stuff. And I don't know what those are yet. If I figure it out, I'll get rich and I'll clue y'all in.
not
But
not
it,
not a
it is,
problem.
yeah, it is definitely going to be a change in terms of jobs. I mean, I think anywhere where you're developing the new idea is where you want to be. If you're an implementer, you may be having issues down the road because a lot of that is going to be automated away.
I
In
like that.
All right. Well, gumboers, you have heard from these two AI experts, and they are also continuing to teach and provide their services as well. Any final words, or maybe how individuals can maybe connect with you both or reach out to you on LinkedIn?
I will be very brief. And I was explaining Pangea, and one direction I said that the government contracting, but we have bigger directions. One is working with healthcare industry. Actually, we met with a couple of executives and we understand the healthcare domain really well. And it seems like there are a lot of stuff that can be improved by Pangea considerably. I mean, I cannot imagine. I mean, the current state of the art seems to be very elementary to us. So we can expand that, we can contribute in that area very much. And another direction that we are having is to work with larger consultancy firms so that partner with them. And since our group is a very diverse group, we have experts in cloud computing, we have experts in cybersecurity, and we have a lot of engineers, mechanical, electrical, mechatronics, robotics. So our first target is predictive analytics in healthcare, but also our second target is manufacturing automation and predictive maintenance and things like that. So we are going from multiple directions, and it is unique expertise. We are like a mobile research center for companies.
Hmm.
Tell us a
Okay.
problem, but it needs to be challenging. We should have fun as well. We don't want to have just any problem. We want to have a challenging problem that we will enjoy tackling and solve your issues. Thank you, Dimitris.
All right. All right.
as far as contacting us, our website is pangeatech.ai. That's PANGEATECH.ai. And we are both available on LinkedIn. I'm Chris Jones. He's Dr. Ali Sekmen.
All right, gentlemen. Well, thank you so much for taking time out of your day to educate us all and give us some tidbits of information around Pangea, and also the revolution that is upon us, artificial intelligence, machine learning, and also different ways and methods of how you can do that, and also how you can leverage your services as well in order to tackle some of the complex problems while having fun. So
Exactly.
everyone, please make sure you also check out the Backup and Recovery Professionals LinkedIn group that I run. And there's over, I just checked the other day, I thought it was 23,000. It's almost 26,000. So it's grown significantly just in the last month. So thank you for joining the group and paying attention to the podcast. And we also appreciate your reviews as well on Apple. So thank you again, gentlemen, and everyone out there. Please stay secure and back up often.